Most browser agent launches sell you a flow. This one sells you a philosophy. Gregor's Unix browser harness says you can stop wrapping a language model in layers of browser framework ceremony and give it a thin path straight into Chrome. The pitch is blunt. One WebSocket to Chrome, no framework, no Rails, and a harness that edits itself when it is missing a helper. It is built to sit beside coding agents like Codex and Claude Code, and the local story matters here. The point is to work against your real browser on your current machine, in a setup that can stay fully local when you want it to. The source post that kicked this off is image first, not demo first. The launch image gives you the headline, the mystical art, and 4 promises. Self-healing, direct CDP, no framework, and drop-in support for Claude Code and Codex. Then the actual repo link lands in Gregor's reply. That matters because the real proof is not hidden in a polished teaser. It is in the public repository, the README, the install guide, the helper file, and the browser setup screenshot. So instead of pretending this tweet contains a full product walkthrough, this video uses the post as the claim and the repo as the evidence pack. The core story is the one right in the hero block. An agent wants to upload a file. It discovers that upload_file is missing from helpers.py. Then it edits the harness, adds the helper, and finishes the task. That is the whole thesis in miniature. The harness is not meant to be a frozen tool palette. It is meant to be a small, editable control layer the model can inspect, extend, and reuse. Even the opening docstring of helpers.py says, read, edit, extend, this file is yours. That line is not subtle. It tells you the repo expects modification as part of normal operation. And on GitHub, helpers.py is visibly active, with recent fixes landing right on the file. Under the hood, the repo is tiny on purpose. Run.py is just a few dozen lines. Helpers.py exposes the browser primitives, things like goto, click, type_text, JS, upload_file, and a raw CDP call. Admin.py handles daemon startup and remote browser bootstrapping. Daemon.py holds the WebSocket connection and the Unix socket relay. The architecture written in the skill file is almost aggressively simple. Chrome, or a browser use cloud browser, flows through a CDP WebSocket into daemon.py, then through a local socket into run.py. That simplicity is the argument. If the model already knows how to reason, then the harness should stay small enough that the model can understand it, patch it, and keep moving instead of fighting a giant abstraction stack. The install flow makes the local browser angle very concrete. First, clone the repo and install it as an editable tool with UV. Then register the skill with your coding agent, so Codex or Claude Code knows to read install.md, then skill.md, then helpers.py. If the harness can already attach, great, you skip the manual ceremony. If not, the fallback is explicit. Open Chrome //inspect/ remote debugging, tick the checkbox that allows remote debugging for this browser instance, and click Allow if Chrome asks. The repo is very clear about the goal. Connect to the users already running Chrome. Reuse a real profile. Prefer the browser they are actually using, not a secret second browser the user never sees. The bigger browser use context explains why this repo looks the way it does. In the bitter lesson post, Gregor argues that agent frameworks keep freezing bad assumptions into the control layer. If the model is already good at reasoning, every extra planning wrapper and rigid action abstraction can become a constraint. In the skills post, the focus shifts from one run to repeated runs. The harness learns site-specific patterns, saves them as domain skills and interaction skills, and lets future agents start with less fumbling. In this repo, you can see that split directly. There are domain skills for real websites and interaction skills for the annoying browser mechanics that always come back: tabs, uploads, dropdowns, dialogues, iframes, and scrolling. So browser harness is not just a thin browser bridge. It is a thin browser bridge plus a memory of how the web actually behaves. So who is this really for? It is for people who already trust coding agents to do real work, but hate how often browser automation becomes a nest of wrappers, brittle selectors, and hidden state. It is also for people who want a local first path. The repo can attach to your live Chrome. The file structure is small enough to read in one sitting. And the public skill files show that the team wants reusable site knowledge to live near the harness instead of vanishing after every run. The trade-off is obvious too. This is young software. A tiny repo gives you flexibility, but it also puts more responsibility on the agent and the operator. If you want a fully managed product, this will feel raw. If you want control, it will feel refreshing. The cleanest way to read this launch is not, "Here is a magical browser demo." It is, "Here is a very opinionated attempt to shrink the browser control layer until the model can actually work with it." The X post gave us the claim. The repo, the install guide, the helper file, and the official browser use writing gave us the proof. And the key promise is still the same one we started with. This can sit beside the coding agent you already use, connect to a real browser, and stay close to a fully local setup when that matters. If that trade-off sounds appealing, the repo is public, the files are readable, and the experiment is already live.